Hi everybody and welcome. Today we're going to be talking about calculating the area and perimeter of composite figures. So our goal after watching this video, we'll be able to again identify the area and perimeter of complex composite figures. So starting off with the real world example, where does this apply? Where are we going to see something like this? So if you've ever seen like the side of a house, a couple things you might have noticed. The first is that on a house like this, if you want to paint it, you need to know, well, how much area do you need? So it's not just a simple, let's calculate, this little highlighted area here. Let's just calculate this rectangle. Well, no, we also need to calculate the triangle on top of it. So the side of this house is actually a composite figure because it's composed of multiple shapes. We have the square that we need to find the area of and the triangle that we need to find the area of in order to paint. Because if you're painting, you don't want to have way too much paint. You also don't want to have too little paint and run out halfway through. So important to know exactly how much we need. The second thing, finding the perimeter of something like this would also apply because if we're just looking at the edges of these two shapes and we're trying to put on, let's say, like some white trim, you're not going to put trim across the center of it. You're just going to want to put it on the edges. So an example of finding the perimeter, again, not of a rectangle and not just of a triangle, but of the outside of when we put both of those shapes together. So a real world example of where you might see something like this, composite figures are extremely common because very infrequently do we see shapes that are just, your simple squares, circles, and triangles in the real world. Often, to make things fit, we have combinations of those. So think of composite figures as combinations of common shapes that we already know. So let's get our definition down here first. Composite figures. And these are shapes composed of multiple other shapes. So again, a square, this is not a composite figure, but if we have a square with a triangle hat, that would be a composite figure. So again, multiple shapes put together. So a couple things that we're going to do with them. So first, something like finding the area. So my advice to you, if you're finding the area, and we're starting with number 5, it's going a little bit out of order, is to break it down into the shapes that it's made of. So something like this, again, let's break it down into the 3 distinct shapes that we have here. And again, we'll go through and we'll do this one step at a time. So it's telling us for shape number 2, I just realized I wrote 2 twice. I don't know what I was thinking there. Let me go back here. So made of 3 shapes, 1, 2, and 3. We'll start off with shape number 2. The length here, this side is 15. We know that the entire bottom of our figure here is 30, and they take 8 millimeters away, so we're left with 22 to split evenly between here and here. So if we have 11, 8, and 11, that gets us to the 30. So it looks like we have 11 here. So the area of shape number 2, we're going to see is 15 times 11, or 165. Next, for shape number 1, we're being told here that we go 8 across. And then we know that this is a length of 10 from here to here, which means that the leftover length to get to the full length of 15 is 5. So an 8 by 5 shape is 40 for the area. And then finally, shape number 3 is actually a direct repeat of our second shape. So we can call that a 165 as well. So take the area of each of those 3, add them together, and we'll get a final answer of 370. So the challenge with area is not calculating once you know the edges, it's finding the edges that we don't know. So they'll give us things like, and I'll highlight some of these, like this 30, and then this 8, and then this 10 that are partial pieces, and even the 15 here, again, that are partial pieces of our shapes, and it's our job to kind of find out what do they mean. So the 10 goes from here to here, and that means that we don't have this missing segment that we identified as 5, but we know that the whole length of this shape is 15, like they give us right here. So you know that 10 plus something gives us that 15, so you know that it has to be 5. And that gives us the edge of shape number 1. And then the same thing for the bottom. If we know that this is a length of 8, we know that the whole thing needs to be 30, again, setting it up like so. So my advice, my recommendation is always break it out into the individual shapes and find the area of those individual shapes. So something like here, we have a triangle with a base of 8 and a height of 6. Base of 8, height of 6, and we also have a rectangle with a length of 10 and a height of 8. So try that one next. Find the area of both of these shapes, and then add both of those areas together to get the full area of that composite figure. Secondly, we are also looking at perimeter. So perimeter, again, our job here is just to find the length around the outside, the length of the edges here. So once more, it's our job to fill in any side that is missing. So they give us 1, 2, 3, 4 of these sides, and now it's our job to fill in the lengths that we don't know. So we know if we brought that into a section, that would be 6. Brought this into a section here, that would be 7. So we put 6 and 7 together. This entire side should be 13. And then finally, our missing section, our squiggly line right here. We don't know that, but we do know, again, this big shape here is 8. We know that the whole thing is 13. So 8 plus something gets us 13, or 8 plus 5. So again, our job now is to take each of these known edges and add them all together. And when we do that, again, I'll write this out for clarity. 13 plus 5 plus 7 plus 8 plus 6 plus our second side, that's 13. Then we will be able to find the outside, or the perimeter, of this shape. So 13 plus 5 plus 7 plus 8 plus 6 plus 13 gets us a full perimeter of 52 meters. And again, looking through, we did what we needed to do. We're in good shape. So let's do the same thing. Break out all of these unknown sides. Maybe we'll be using like the Pythagorean theorem to calculate our length of C here. We'll be filling in things like 12 on this side over here. And again, carefully going through, calculating if we need to unknown side lengths, because again, sometimes we won't be able just to identify and see it. Sometimes, like here again, it might be like an a squared plus b squared equals c squared triangle. But again, if we have the tools to do it, we can and we should. And then as a final note here, we'll say number 2 is an optional challenge question. So if you feel like you can do number 2, 100% go ahead and do it. We'll say it's optional challenge, but if not, we'll go over that one in class. So save your questions for in-class time, and we can clarify anything that we have there. But all the other questions, please answer them fully. They are needed.